Okay, so this is our demonstration of our virtual reality program where we visualize a stochastic diffusion reaction. So this is the environment that we created. It's a big room created with Unity assets, and we have projectors here which our simulation visualization takes place. And I have two controllers. One of the controllers I use for moving around, and I move around by pressing the touchpad. So I aim the laser where I want to go and click the touchpad, and I go there, and I can also look around. And the other touchpad is used to manipulate the simulation, which I will show later. So I move to the start screen, and here I can decide how many time steps I want. So the way I choose, I click on the menu, is that I put my thumb on the touchpad, and then the laser comes out from it. And then I press the trigger button, which will click the button. So if I target it with the laser and then press the trigger button, then I can drag these time steps. So right now I only want to make an easy demonstration, so I'll have a few time steps, around 1000. And then I move the laser to the submit button and press the trigger again. And here we can see that we have a couple of files to choose from that I created specifically for this demonstration. As you can see, there are 3 movies, one of an E. coli mesh, one of a flat mesh, and one of a sphere mesh. And if I want to do a sphere mesh simulation, I press sphere, and then I press the movie sphere. So right now we have the mesh over here. Right now it's 1000 time steps, so it will take around 1 minute for it to finish. But as we can see, there is a graph that shows us information about the simulation. And the graph will move as where I look. So if I move to the other side of the room, it will still face me. And here is our simulation. These spheres are molecules. There are 10 types of molecules that we can choose from. And as I move the simulation forward, if I click on the right side of this controller, I move the simulation forward. And if I click on the left, I move it backwards. And if I press up, we have a movie. And if I press down, I stop the movie, and if I press down again, I move backwards. We can also see that when I time step forward, I see that this yellow dot moves forward in time. And we can see the number of particles changing. So right now we have something happening here, and if something should happen here, and if we look closely, there's an explosion and new particles are created. Another thing we can do is if I press the select button on the left controller, I change the particle type that we display. So now I only display S11.
Kolla lite mer uppåt.
And if I press it again, I get S12 and S2, S21, S22, S3, S31, S32, S4, and go back to all particles. So now we can see that the simulation is going and stuff's happening. And one interesting thing we can do is if I target one of the molecules and press the left trigger button over here, then a trajectory is generated. This shows us where the molecule has been. And if I time step now, I will time step backwards. We see that it follows this trajectory. And I can generate new trajectories on the fly, like this. And I can also move forward, make a new trajectory, and look at this molecule. I can also make this, I can move this cell around, this mesh. And I can make it, I do this by pressing this button, the grip button on the controller. I have to put it so I can touch the molecule, and then I press the grip button, like this button, and then I can move it around. And also if I do it with the other controller, move the left controller to the cell, press the grip button, then I can make it bigger and smaller. So I can make it really small if I want to. I can also, it's maybe hard to see, but it's a movie right now. Or I can make it really big. Like this. I can make trajectories here too. And I can even make it even bigger if I want to. And I can look at the trajectories when I'm really small. And I can see how the molecule is moving. Can move around like this. I press the grip button, take hold of the cell, and press the other grip button, and then I move like this, like climbing. So this is the demonstration of a simple simulation. We can also press the reset button, then everything will reset, and then we can do this all again. I will choose quite a small file that has a bit more going on. I will choose around 200 time steps. And I will choose the file hybrid small dt on a sphere mesh. So this is our file. Right now you can see that we have all particles displayed. We see the graph over here of all particles. And if I press the left select button, I can change. So now we have all particles. If I press again, we have only S1. If I press again, S11. And I can go through all of these. So now I would like to start a simulation with all particles. We see we have all particles over here, and I press the up button on the left touchpad to start the movie. And we can see this is moving and a lot of stuff is happening. And now I would like to move back to the beginning of the file. Then I press down here on the left touchpad and move back. So this is all particles. Now I will only want to look at S1. So I cycle through this to S1. We see the number of particles of S1 is decreasing. And I would like to see if this is true by looking at the simulation. So I do a movie again and move a bit closer to see it all. And I press up here to start the movie. And we see that a couple of them are removed by explosions. So this seems to be all fine. Then I move back and revert the simulation to the beginning, like this. Then I press the select button again to change the type from S1 to S11. And let's see what happens if we make a movie of this. And as we can see, a lot of molecules are being popped up. We can see that it starts from 0 and moves up to 19. And I move back the simulation. Yeah, let's see that one more time. So now I'm quite close and I do the movie again. I see a lot of particles are being popped up. And we can also look at the trajectories of these particles by pressing the left trigger button and selecting them with the laser. And moving back again. And then I would like to cycle through to another type. I'll cycle through to S2. If we look at this, we get these black molecules. Quite hard to see from your screen perhaps, but I can see them very clearly. So now I would like to show another feature. As I said before, we have support for multiple simulations over here, multiple holograms. Let's see that in work. So I'll just choose 50 time steps just to choose something. And I'll pick a sphere mesh and I'll do a hybrid small dt. And I'll create multiple of these. As you can see, I can click a lot of times on this. And new graphs will pop up every time I push the button. So right now I have a lot of graphs at the same time. And as you can see, each of these simulation files all have an information graph associated with them. Right now they're all the same file, but in principle they could be any simulation file at all. And we also have a stat screen over here that visualizes the mean value of all of our simulations in the room. So if I look over here, I see these are all the particles at display, and we start at 0 and we start at 100 particles and then we move up to 112. We can also change what we look at. So right now we are only looking at S1 particles, and we can move to S11, and I do this by pointing the laser at the slider and pressing the trigger button to move it around. So these are all S1, these are S11, these are S12, and these are S2. And like if we look at S1 for example, this corresponds to this graph if I press the select button one time. So right now we have S1 over here. Oh, let's take S11 first instead. So we have S11, it moves up like this, and over here we have S11, and it moves up like this. Go. So we also have support for quite a number of particles. So right now I'll do 300 particles. And you see this mesh is packed with molecules that are reacting. And we can make a move of this, of course, like before. And we also have a file that have 1000 particles in it. So it takes quite some time to load, but once it's loaded, it's packed. And this is kind of the limit performance-wise, since the program starts to take a lot of performance right now, since there are a lot of information in this file. But we can still move it around and we can still time step it. But it's taking considerably more time. And if I press the movie button, the program will be really slow. Okay, this is my final feature demonstration. So I would like to show our support for different meshes. So I will choose around 1000 time steps this time. And I will choose a sphere mesh. And I will choose an E. coli mesh. And I will choose a bumpy mesh. So if you watch carefully, I chose the mesh first, and then I chose the file which belonged to the mesh. So if I picked sphere here, I picked the movie sphere. If I picked E. coli mesh, I picked the movie E. coli. And if I pressed bumpy mesh, I picked the movie flat. And right now we have 3 simulations here with all different meshes. And this mesh you're all familiar with. So let's not look at this one to begin with. Let's look at this one. So this is it's basically the same thing that I showed you before, but it's on a different mesh. So I can make a movie of this, I can pick it up, move it around, I can make trajectories. And I make trajectories by pressing the left trigger button while I aim a laser at the one molecule. And I can make it bigger or smaller. And I can see that the time dot moves as the simulation goes. Another thing I would like to showcase is that we have support for a simulation in the cloud. So I choose the number of particles I want, maybe like 87, and I press new sphere simulation. And right now you're seeing that the simulation is going on outside of this program in the cloud and being downloaded to the computer and being created over here. It's 1,000 time steps, so it takes some time before it's finished. But as it's being finished, I can show you, well, it's finished now. So yeah, this is another simulation. We can move this around and we see stuff is happening. We pick it up, make it bigger, make it smaller.